Okay, we're going to now go back into Chapter 1, Basic Concepts. And we're going to look at deduction and induction. These are the two main forms of argument styles that you will see in this book.
Section 1.3 distinguishes deductive arguments.
For the most part, you will be seeing, sorry about that, for the most part, for the next three chapters or so, for the first two major chapters after we cover Chapter 3, that is chapters 5, 6, and some of 7, you'll be working only with deductive arguments after the course. For most of the time in your daily life, a lot of times you're working with inductive arguments. That is to say, you're working probabilistically. That is, you've gone to a restaurant before, and you're saying what probably will be the case if you go to the restaurant the next time. I've been to this restaurant 4 times. Each time the meal has been bad. Therefore, probably the meal will be the meal will not be good this next time. For deductive arguments, they necessarily follow. Think of it like mathematics. It's automatic that when you're doing a mathematical proof, that the next thing follows, right? That the conclusion follows from the premises. I won't bother with any of that since I don't want to get lost in mathematics, but mathematics is a deductive enterprise for the most part, except for statistics. Many arguments we use in daily life are inductive. That's not to say that deductive arguments are not important. We actually make those all the time as well. So there are two types of arguments, obviously, deductive and inductive, that we're going to be looking at. A deductive argument is one where the arguer claims that it is impossible for the premises to be true and the conclusion to be false. That is, if the premises are true, the conclusion must be true. For inductive arguments, so therefore in a deductive argument, it follows necessarily from the premises. And so you'll often see that terminology in deductive arguments. It's necessarily the case. So Barbara is taller than Carol. Carol is taller than Denise. Therefore, it necessarily follows that Barbara is taller than Denise. So if it's true that Barbara is taller than Carol, Carol is taller than Denise, it must be the case deductively that Barbara is taller than Denise. This is a typical deductive argument. On the other hand, an inductive argument is an argument in which the arguer claims that it is improbable that the premises be true and the conclusion false. Another way to put this is the conclusion is only probably true. Not necessarily true, but probably the case. So 90%, this example is not one liked by me because it follows the stereotype of women as nurses, but we'll use it for now. 90% of the nurses in St. Luke's Hospital are women. Therefore, since Anderson is a nurse in that hospital, it probably follows that she is a woman. We could also do this in another way. 60% of the doctors in St. Luke's Hospital are women. Therefore, since Anderson is a doctor in that hospital, it probably follows that she is a woman. Therefore, in other words, what you're looking for is probability. Again, this is only 90% probability. It's not 100%. With deduction, it's necessarily the case, always the case, 100%. Whereas in inductive arguments, it's only probably the case. So in the two examples that I gave, if 60% of the doctors are female, and Anderson is likely, that is 60% a female. But that's not always the case, right? Or in the example given here, since 90%, 9 out of 10 nurses are females. In this example, not one that I would use necessarily, Anderson is a nurse in that hospital. It probably follows that she is a woman. Again, there's a 10% chance that she's not, that Anderson is a male. So deductive arguments are necessary reason Inductive arguments are probabilistic reasoning. And so you'll see that later on when we get to chapters on the chapter on statistical reasoning. That's probabilistic reasoning. So in distinguishing deductive arguments from inductive arguments, look for 1, special indicator words, and 2, the actual strength of the link between the premises and the conclusion. So special indicator words for deductive indicators are necessarily the case, that it's definitely the case, it's certainly the case, or absolutely the case. Now, as in the conclusion indicators and premise indicators from chapter 1.1, it doesn't necessarily follow that these words are always going to be used. But many times they will be. And so that helps you to decide whether something is deductive or inductive. Okay, so it serves as a signal. Okay, however, sometimes this language is used only for rhetorical purposes, so you have to be on the lookout for that. Somebody might say 90% of doctors in this hospital are female, therefore it's necessarily the case that Anderson or Sam or other more androgynous names is a female. Well, it's not necessarily the case. So sometimes people use it rhetorically to force you into believing something that is only probable. So be careful with that. But for the most part, in this course, I'm not trying to, with questions and answers and so on, I'm not trying to fool you. If you see those indicator words, I'll try to make sure that on examinations and so on, it's not meant there to fool you from thinking something's deductive or inductive. So a special indicator for induction, right, are the words probably, likely, plausibly, reasonably to conclude. Probably is the typical one. 90% of the doctors, I'll replace that, in St. Luke's Hospital are women. Therefore, since Anderson is a doctor in that hospital, it probably follows that she is a woman. So inductive indicators, again, are probably, likely, plausibly, reasonably to conclude. The word must is one that's ambiguous. Watch out for that one. It could say, it could signify, that is, it could suggest that something is either necessary, that is, it's a deductive argument, or it's probable, that is, an inductive argument. So the actual strength of the link between the premises and the conclusion is another way to look for the distinction between induction and deduction. If the conclusion does in fact follow necessarily from the premises, then of course the argument, as we know from 1.1 and 1.2, is deductive. So if Barbara is taller than Carol and Carol is taller than Denise, it must be the case. Right? It follows necessarily that Barbara is taller than Denise. But if the conclusion does not follow necessarily from the premises, but it follows only probably, then all things aside, the argument is just simply inductive. Right? 90% of the doctors in St. Luke's Hospital are women. Therefore, since Anderson is a doctor in that hospital, she is a woman. The conclusion does not follow necessarily from the premise, but it does follow with 90%. Certainty is not a good word here. It follows with 90% probability. Right? There's still a 10% chance, of course, that somebody named Anderson or other words might be a woman or in fact trans these days. Right? In other words, there's other gender identities. Okay? So let's look at some practice problems. So Bill is a farmer, and Bill's only brother is Bob. Therefore, it necessarily follows that Bob's brother is a farmer. How is this argument best interpreted? So let's look at this. Bill is a farmer, and Bill's only brother is Bob. Therefore, it necessarily follows that Bob's brother is a farmer. Okay. Now, what's the connection between Bill being a farmer and Bill's only brother being Bob? Is there a necessarily connection between Bob being a farmer and Bill being a farmer? Would you think it's deductive? Let's see. Well, necessarily does indicate that the argument is deductive, right? And so the conclusion does in fact follow necessarily from the premises. Okay. Relatively few freshmen came to the party. Therefore, since Susie came to the party, it is likely that she is not a freshman. How is this argument best interpreted? Well, only a few freshmen came. So it's possible Susie came to the party, but it's likely that she's not a freshman, since most of the people there at the party, if Susie was in fact at the party, that Susie is not a freshman, since it's only a few of the people there that were freshmen. So this is a probabilistic or inductive argument. Right? So the word likely indicates that the argument is inductive. Also, the conclusion does in fact follow probably from the premises. Every carpenter is a woodworker, therefore it necessarily follows that every woodworker is a carpenter. Every carpenter is a woodworker, therefore it necessarily follows that every woodworker is a carpenter. How is this argument best interpreted? Deductive or inductive? Well, you would say it's deductive, right? It necessarily follows, right? The conclusion does not in fact follow necessarily from the premise, but the word necessarily indicates that this is an inductive argument. So this is where we first come upon what is an invalid argument, and yet it's still an attempt at a deductive argument. And I'm sorry to add that confusion in early, but we must recognize, as we're going to do in the next chapter, part of the chapter 1.4, that there are going to be invalid deductive arguments. That is, arguments that attempt to be deductive but don't work. Just because every carpenter is a woodworker, it doesn't follow that every woodworker is a carpenter. You can have woodworkers that are not carpenters. I don't have an example that's coming to mind, but one can imagine that there are people who are non-carpenters, but who are also working with wood, such as the people who work with wood when they're putting together the railways, such as the people who are working, woodworkers who work in building buildings and so on. They may not necessarily be carpenters. Okay? But it is nevertheless a deductive argument. Okay, the person's starting to say it's necessarily so. Jack has lost every poker hand during the last 2 hours, therefore it is plausible that he will win the next one. Right? How is this argument best interpreted? Now let's look at this argument. It is plausible, so we now know it's an inductive argument. But we also know something else. Read this argument again. Jack has lost every poker hand during the last 2 hours, therefore it is plausible that he will win the next one. We will see this when we get to fallacies, that this is an inductive argumentative fallacy. Just because you've lost a number of times in poker doesn't mean your win is coming soon. Every hand in poker has exactly the same number of chances, unless the casino is trying to rip you off. This is known as the gambler's fallacy, that we think we've lost so long that a winning hand must be coming along. Okay? But nevertheless, it's an attempt at an inductive argument. It's a plausible one. It's not a good argument, but nevertheless, it's an attempt at an inductive argument. Right? The conclusion does not, in fact, follow, probably from the premise, but maybe Jack does not know how to play poker. But the word plausible indicates that the best interpretation is inductive. It could also be just simply the case that Jack may be losing every hand, and it's just a night where his chances of winning are 1 in 5, and they're 1 in 5, and they're 1 in 5, and they're 1 in 5 every time. But just because you've lost a number of times, well, it's an 80% chance each time. And that doesn't change for the next time either. We'll see that in chapter 3. No armadillos are hedgehogs, therefore no hedgehogs are armadillos. So how is this argument best interpreted? Well, we get the therefore, which is where we've seen before for inductive arguments. No armadillos are hedgehogs, right? Therefore, no hedgehogs are armadillos. When we get to Venn diagrams, you'll see that this is exactly a deductive argument. Now, is it one that we can take to heart? Yes. That is to say, is it valid? Yes, indeed. Although there are no deductive indicator words, there is a conclusion indicator. The conclusion does, in fact, follow necessarily from the premise. Thus, the argument is deductive. Right? There are no armadillos that you've ever seen in the world that are hedgehogs. They can't be both at the same time. So some arguments contain neither deductive nor inductive indicator words, as I've said, and the conclusion does not necessarily follow either necessarily or probably from the premise. Okay? So this leads us to the third criterion for distinguishing deductive from inductive arguments, which is the form or the style of the argument. Okay? So arguments have typically a deductive form of style. One of these arguments is based upon mathematics. Arguments based on mathematics. The conclusion depends on some form of arithmetic, geometry, or algebraic procedure. Okay? So for example, since x plus y equals 7 and x equals 4, it follows that y equals 3. Now, for now, don't panic. This is one of the few times that you're going to see actual mathematics in these videos. But I want you to know that mathematics tends to work deductively. Okay? That is, x plus y equals 7. We know that if we take away 4, that y must be 3. Right? You've done this in algebra in high school. Okay? But do not worry. You will not see this often. It's just to know that when it comes to mathematics, and if you see mathematics on an exam or in the homework, to know that is going to be a deductive argument, unless it's a statistic. So arguments from definition. The conclusion depends merely on the definition of a word. This is going to be a deductive argument. Dorothy's cancer is pernicious, therefore it is deadly. If something is pernicious, right, it is deadly. Okay? It follows by definition, right? It can't be any other way. A categorical syllogism. We'll be covering this a little more later, and I want to be clear, okay, that that will be a difficult section, but I think you'll do fairly well. Categorical syllogisms will come up specifically when we study Venn diagrams, if we study Venn diagrams. So 2 premises, 1 conclusion. All 3 statements begin with all, no, or some. The verbs are going to be are or are not. This is what you see. Okay, so it's going to be a categorical syllogism, comes to us down from, it's first formalized in Aristotle, back in the 4th century, BCE or BC. You have 2 premises and then 1 conclusion. So all cats are mammals, no birds are mammals, therefore no cats are birds. Okay? This is a, not a classical, but the formula is a classical one for a categorical type of deductive argument. All categorical syllogisms are deductive, right? There are, however, hypothetical syllogisms, is a deductive argument where it consists of 2 premises and 1 conclusion, such that one or both of the premises is a conditional statement. Okay, let's see how this works. If habitats are being destroyed, then animal species will perish. Habitats are being destroyed, so we're saying this part is true, therefore animal species will perish. Okay, that is a deductive argument. There's no probability there. If this is true, then this is true. We're saying this is the case, so therefore that must follow. This is the conclusion. Okay? Premise 1, this is premise 2, and this is the conclusion. Let's take up another. This is premise 1. If ice storms occur, then power lines snap. If power lines snap, then electric outages result. Therefore, if ice storms occur, then we go down to the second one, electrical outages result. We'll see this again later. Okay? But that is a perfectly good deductive hypothetical syllogism. There's also what's called a disjunctive syllogism. This is 2 premises, 1 conclusion. 1 premise is a disjunctive statement. So let me be clear. Disjunctive just means either or. So either Chicago is in Wisconsin or it's in Illinois. Chicago's not in Wisconsin, therefore Chicago is Illinois. So what happens in a disjunctive syllogism is if one side is false, it's necessarily the case that the other side is true. Okay? Right? And so we have premise 1, right? Premise 2, conclusion. So let's now work on some practice problems involving these ideas. Martha is gregarious, therefore she talks a lot. Now, what does that sound like? What does gregarious mean? It means somebody, well, it means more than that talks a lot, has a good sense of humor and so on, but part of that is that you have to talk a lot, right? So that is an argument from definition, okay? If medical marijuana, now we know that we're going to get something hypothetical. If medical marijuana is being approved, then drug laws will be relaxed. Medical marijuana is being approved, therefore drug laws will be relaxed. This argument is deductive because it is a hypothetical syllogism, right? Whenever you see the if-then, you're dealing with a hypothetical syllogism. If medical marijuana is being approved, then drug laws will be relaxed. Well, what happens is medical marijuana is being approved, okay? Then it's necessarily the case that drug laws are being relaxed, right? We know that. If somebody is a politician or a state relaxes its medical marijuana laws, as is being done across the U.S., drug laws are indeed being relaxed overall, at least as it goes for medical marijuana. Okay. All pesticides are substances that kill. Right, so let's do another problem. All pesticides are substances that kill. All substances that kill are dangerous to humans. So, therefore, all pesticides are dangerous to humans. Right? This argument is deductive because it is what? An argument from definition, a disjunctive syllogism, or a categorical syllogism. This seems to be an argument from definition. Why? All pesticides are substances that kill. Any substance that kill, by definition, is dangerous to human, and therefore all pesticides are dangerous to human beings. Now notice that this is not necessarily the case. Is it true that all pesticides are substances that kill? Now, there is an argument and debate about the amount of pesticides people want used on farmland and that therefore get into our food supply, but leave that aside. This is a deductive argument because it's saying it's always the case, it's always the case, and therefore it's always the case. Okay? So it would be an argument by definition, right? So, sorry. It is a disjunctive. Nope. And, gosh, a categorical syllogism. The argument is a categorical syllogism. If all pesticides are substances that kill, then all substances, and so on. Sorry, it's a categorical syllogism. We really fouled that up for once. It's like it has the same format as all men are mortal. Socrates is immortal, therefore this is immortal. I love when I reach for my coffee and then don't pay attention to which buttons I'm hitting. But let me take a sip of that. So that again was a categorical syllogism. Either Keats or Shelley wrote Ode on an Eton Urn, but Shelley didn't write it, therefore Keats wrote it, right? So this either or tells us it is disjunctive, okay? Which is another way of saying it's either or. Either one is the case or the other is the case. One is false, therefore the other must be true, okay? This is a deductive argument, and it is a disjunctive syllogism. And this time I finally hit the right buttons, okay? This square A is inscribed in circle B, therefore the area of A is less than the area of B. This argument is deductive because it is obviously an argument based upon mathematics, right? We're dealing with circles, we're dealing with geometry. Okay, anytime you see that, you know that you're dealing with a deductive argument. Again, the only time you'll see any kind of argument involving mathematics that it may be probabilistic is statistics. So let's look at the form or style of arguments that are inductive. One is a prediction. The premises relate to the present or past. The conclusion relates to the future. An example, experimental trains that levitate magnetically are running in Japan and Germany. Thus, before too long, we will have such trains in the US. Now that's a prediction, right? Is it necessarily the case that we will have such trains in the US? No. As far as I know right now, I don't believe we do have them. Although we might have them at Disney World or something like that. But let's leave the argument just as it is without looking to the actual world. Unfortunately, in logic and looking at the form of arguments, you often, for now, have to be told, forget about the real world, because there might be trains that are levitating magnetically somewhere in the US and I'm unaware of it, right? But experimental trains that levitate magnetically are running in Japan and Germany. Thus, before too long, we will have such trains in the US. An argument from analogy depends on the existence of analogy or similarity between two things or situation, right? This is important kind of argument. We make this kind of argument all the time. But it is only probabilistic, because one of these two things might be related, or they might not be. It depends on the strength of the analogy. Okay, lions are similar to tigers. Lions need a high protein diet. Therefore, tigers need a high protein diet too. Right? Is that necessarily the case? No, it's an analogy. They're similar. So since lions are to protein as tigers are to protein, that's the analogy. Right? But it's not necessarily the case. Now, for those who know about lions, know that they probably tigers they do need, in fact, a high protein diet. But that's only probabilistic based upon. That is only probable based upon this argument itself. Another kind of argument is a generalization, which proceeds from knowledge of a sample to a claim about a whole group. So according to a random sample, this is all statistics, a random sample of 1,000 voters, 600 said they intend to vote for Johnson for state senate. We can therefore conclude that about 60% of the population will vote for Johnson. Notice we're taking a small segment of the voters, which we do all the time in polling, and we use that to make a generalization, right? But we know that often that is only probable, that is often wrong. For example, in the 2016 election, in much of the polling leading up to the election, it looked as if Hillary Clinton was going to be winning over Donald J. Trump. What happened in the election, right, was in fact that Trump won, specifically, though according to the Electoral College, but nevertheless, the polling data in those states which gave him a win in the Electoral College had shown him slightly behind. But we will talk we should talk much more about statistics at a later point. Okay? So this is a typical inductive argument. Right? It's only probably the case. Another inductive form is an argument from authority. Concludes that something is true because some authority or witness has said that it is. Now, I should say that not all authorities are actual authorities. Somebody who says, according to this radio personality, Donald Trump, or I'll use Hillary Clinton again, or another person is a liar. Therefore, it's probably the case that she is a liar. Well, is a radio personality or somebody on TV a real authority on that? No, we might. For that, we might look to other sources of authority on whether or not either of those two or others are liars. So, for example, the president of Great Northern University issued a statement that enrollment is up for the current year. From this, we conclude that enrollment is indeed up at that school. Right? Now, why is this an example of an inductive argument? This would seem to be deductive. The president says this, it must be the case. Well, perhaps the president has collected the wrong data. Now, the president should be an authority on this, but authorities are not always 100% correct. And so we may conclude that enrollment is indeed up, and we probably should, but it's not 100% the case. Okay? It is not necessarily the case. Okay? The president may have been misinformed. An argument based on signs proceeds from knowledge of the sign to a conclusion about what the sign says. A sign is sort of any kind of message produced by an intelligent being. So let's see what this is. Don't worry, this looks confusing. But, right? The label on this package of cookies says that each cookie has 60 calories. Thus, each cookie must have about 60 calories. Now, this is a good inductive argument, right? You see what's on the package, and therefore you believe it. But it has been the case before that companies have been found to mislabel their packages, and thus it is only likely the case that each cookie has about 60 calories. We know that they won't be exactly the same in each. Another inductive form is a causal inference proceeding from knowledge of a cause to a knowledge of effect, or vice versa. Okay, let's see what this means. Mount Rainier has a crater at the top. It must have been a volcano at one time. Now, we know that many mountains that have craters at the top are volcanoes, but not all mountains that have craters at the top are volcanoes. This is only probably the case. Okay? This argument proceeds from the effect to the cause. Many arguments that proceed from cause to the effect are also predictions, by the way. So, obviously, now let's work out some practice problems involving inductive argument forms. The first piece of candy I tasted from the bowl was mint flavored, and so the second, third, fourth, fifth, and sixth. It must be the case that all the pieces of the candy are mint flavored. Right? So this argument is inductive because it is what? Is it an argument from analogy? What's the analogy being made? None. Is it a causal inference? No, there's no causal inference being made. That is, we're looking from the effect back to the cause. No, it's a generalization. We've tasted 6, and then we're saying something about the whole of the entire bowl of candies. Right? The argument proceeds from knowledge of a sample to a claim about the whole group. Right? It could be that the 7th or 8th piece of candy that you pick up is not, in fact, flavored mint. Commercial rockets transporting tourists to the moon and back will be a reality in a few years. Already 1,200 people are on a waiting list, and tourists are paying big bucks for flights to the edge of space. Okay, so commercial transporting to the moon and back will be a reality in a few years. What does that sound like? It sounds like a prediction. People are on a waiting list, right? And tourists are paying big bucks for flights to the edge of space. Right? It is a prediction, right? It's saying what's missing here is the obvious conclusion. We will be having these flights soon. But of course, as many of you know, predictions about actually having these commercial rockets have been going back to a long time, 30 years, since we first put men on the moon. An eyewitness stated that the bank robber had a gray beard. Since the witness has no motive to lie, we conclude that the robber did indeed have a gray beard. Right? This argument is inductive because it is what? It's an argument from authority. Why is this person an authority? Because they are an eyewitness. But we know that eyewitness accounts are not always 100%. Right? It's probably the case that the robber did have a gray beard, but we don't know anything else about the eyewitness. What is this person's eyesight like? Right? Are they often a truthful person? Right? Might this person being called an eyewitness be actually in on the job? We don't know. But generally we take eyewitnesses to be an authority. Okay? So the argument concludes that something is true because someone has said that it is. Frank and Andy both like action movies, and Frank just loved the latest film by Keanu Reeves. Therefore, Andy should like it too. Right? This is both probably. Right? Frank is to liking films by Keanu Reeves as Andy is to Keanu Reeves. Right? And so Andy should like it too because it is an argument from analogy. Let's see if that's the case. Let's see if I've been correct. Yes, the argument depends on a similarity between Frank and Andy. Okay, it's an analogy. Now, not 100% of not friends. Friends will not always agree on every movie, but since they both like action movies, perhaps, and Keanu Reeves, for the most of his career, was known for his action movies. Therefore, Andy should like this movie too. But it's not necessarily the case. It's only probably the case. After picking up her English test, Kathy started crying. Apparently, she got a bad grade on the test. Right? This argument is inductive because what? There's a sign. What are we looking at? Apparently, she started crying. Well, that is usually a sign of sadness, and usually one doesn't cry when one gets a good grade on an exam. So this is an argument from signs. Oh, it is not. Why is that not? It is a causal inference. No, it is not. It is an argument from, click OK. Sorry. It's a causal inference. The conclusion depends on the claim that a bad grade caused Kathy to cry. Right. We work backwards from, this tells you your professor needed to check these before he did them, right? We're working backwards from apparently she got a bad grade on the test to picking up her English test, she started crying. So we see the result, and then we guess what the cause is. That's what a causal inference is. But I also think this could be an argument from signs, that we see crying, and she got a bad grade on the test, right? That is, we see some symbol of something, and then we make a conclusion based upon it. It could go either way. I won't ever give you a question like this, okay? Why? Because crying usually denotes that something wrong has happened. Okay, so that could be an argument from signs, but it's also a causal inference. I see the result. I suggest a result because of the cause. Okay. The tag on this painting says $750. The logical conclusion is that the painting costs $750. The argument is inductive because it is an argument from authority, an argument from signs, and an argument from a prediction. Well, clearly this is about a price tag, so it's about a literal sign on the painting, and so it's an argument from signs. So that's less difficult than the last one, which could be an argument from signs or an argument from causal inference. So a final note, arguments that occur in science can be either inductive or deductive. Arguments aimed at discovery of a law of nature are usually inductive. That is, we're looking at an area of space and so on, and then we try to say something about the laws of nature. Arguments that apply a known law of nature to a specific case are usually deductive. Right? E equals mc squared, in general, means that we should find in this particular phenomena that E equals mc squared as well. So let's now work some practice problem involving everything that we've learned thus far. Kidney beans are great in chili, but coffee beans are no less beans than kidney beans. Therefore, coffee beans are probably great in chili too. How is this argument best interpreted? Kidney beans are great in chili, but coffee beans are no less beans than kidney beans. Therefore, coffee beans are probably great in chili. Well, this isn't necessary, right? We see the word probably here. So therefore, it's an inductive argument. Is it a good argument? No. You would never want to eat chili with coffee beans. But nevertheless, it's an attempt at an inductive argument. Right? So what reasons do we give for our answer? Right? Well, we have an indicator word. Right? Is that enough? No. We must check one more box. Which one? Is it the strength of the inferential link? No, it's not a very strong inferential link, but it is the form of the argument, is it not? Yes. The word probably indicates induction, but the conclusion does not necessarily follow either necessarily or probably from the premise. However, the argument does have an inductive form. Kidney beans are great in chili, but coffee beans are no less beans than kidney beans. Therefore, coffee beans are probably great in chili too. What's the form of the argument? Is it an argument from analogy, a causal inference, or an argument from signs? Well, we see nothing in here that's about signs. Is it causal inference? Coffee beans are probably great in chili too. Well, it should be an argument from analogy. Kidney beans are great in chili, therefore coffee beans should be great in chili, right? It's making an analogy between different kinds of beans. Let's see if that is the case, right? The conclusion depends on the analogy between kidney beans and coffee beans. Henry is a misogynist, therefore it follows that he hates women. How's this argument best interpreted? Right? Therefore is a good conclusion indicator, right? This is the premise, here is the conclusion. If one is a misogynist, it necessarily means that one hates women. This is an argument from definition is what kind of argument? It is a deductive argument. Right? So what reasons support the answer? We can select all those that are correct. It follows that, right, is an indicator word for conclusion. It's certainly about the form of the argument, right? But is that it? Yes, that is certainly one of them. It is the strength of the inferential link. Yes, the link is strong, right? If one is this, then one is necessarily this. There is no indicator word. These are indicator words for conclusions, but they are not indicator words for induction. It is necessarily the case, and so on. Right? The argument has indicator words for conclusions, therefore, and it follows that both are conclusion indicators, but they are not indicator words for either induction or induction. Right? Henry is a misogynist, therefore follows that he hates women. Right? This is an argument, as I've said, from definition. Right? If one is misogynist, then it's not a prediction, it's not a causal inference. Every man entering the art show brought a painting, and every woman brought a piece of pottery. Therefore, since there were more women than men entering the show, there were more pieces of pottery than paintings. So every man entering the art show brought a painting, and every woman brought a piece of pottery. Therefore, since there were more women than men entering the show, there were more pieces of pottery, right? This is every, right? Every, right? And so this should be a deductive argument. No? Yes, indeed it is the case, right? Why? Because we are getting indicator words. Therefore, it's the strength of inferential link. Yes, let's submit that. Right? The argument has no indicator words, and it has no form that we've discussed, but the conclusion does follow necessarily from the premises. What about the form of the argument? Well, the form of the argument should be the case as well, right? Although it's saying it doesn't have the form, but it has every, and therefore. It's going to bounce it, but that's okay. Let's move on. The internet is an important part of modern life, probably be an important part of life 5 years from now. How is this argument best interpreted? Deductive, inductive. Well, we see that probably is the indicator word there, so we know that it is inductive. What reasons do we gather? We get the indicator word, right? That is probably will be the case. Is there a strength of the inferential link? Yes, there is. Is it, let's see, is that all? We must check one more box because we also knew that it's the form of the argument, right? We get a simple sentence here, and then any prediction is always based upon we have a sentence or two, and somebody says it probably will be the case. The word probably indicates induction. The conclusion does follow probably from the premise. In 5 years, the internet will probably still be important unless there's the apocalypse, and the argument has an inductive form. Right? So what is the form of the argument? Well, we've already said that it's a prediction. Probably it will be the case. We're talking about the future. Here's another practice problem. The Alpha Club has 6 members. Therefore, it most likely follows that at least 2 of them were born on the same day of the week. Right? Now, why would that be the case? Well, there's 7 days of the week. The Alpha Club has 6 members. It most likely follows that at least 2 of them were born on the same day of the week. Right? It would be improbable if one knows probability rules. It is improbable that all 6 were born on Monday, for example. Right? But is it necessarily the case? No. We can imagine that all members were born on Monday, Tuesday, or Wednesday, or born on different days of the week. So it is an inductive probabilistic argument. Okay? Do we get an indicator word? Yes. It most likely follows is an indicator word. Is there a strength of an inferential link? Indeed there is. Is there a form of argument? Indeed. It is a probabilistic mathematical argument. It's probably telling me that the form of the argument is not the case. The phrase most likely indicates induction, and the conclusion does follow probably, but the argument has no form that we have discussed. It does have a form that we haven't discussed, but we will get to that soon. Here's another practice problem. If casualties occur, then insurers pay claims. If insurers pay claims and insurance premiums rise, therefore if casualties occur, then insurance premiums rise. How is this argument best interpreted? Deductive or inductive? Well, it's deductive, right? We're getting the hypothetical syllogism, right? If casualties occur, and then we go to the second one here, then insurance premiums rise. So it is a deductive argument. What reasons support our well, we don't get one of the indicator words. It's true that we get the indicator words for what is a hypothetical sentence, but we don't get one of the indicator words for necessity. Is there a strength of the inferential link? Yes. Is there a form of argument for the hypothetical syllogism? Indeed, there is. Right? The argument has no indicator words, but the conclusion does follow necessarily for the premise, and the argument does have the deductive form of the hypothetical syllogism. If casualties occur, then insurance pays claims. If insurers pay claims, then insurance premiums rise, and so on. So what form of argument is this? It is the hypothetical syllogism. Okay? These statements have three conditional statements. Here's another practice problem. Magnetic attraction varies inversely with the distance. Therefore, as this iron bar is brought closer to that magnet, the forces of attraction increases. Right? So magnetic attraction varies inversely with the distance. Now this is very complicated, but all this means is, this sounds complicated for those who are not understanding it, but in other words, the farther away magnets are, the less attraction those two magnets have for each other. So this iron bar is brought closer to the magnet, the force of attraction should increase. This is a deductive argument, right? Why? Because it is a scientific law given to a specific case. So the best interpretation is probably, edit that out, the best interpretation is deductive. That crazy looking man giving a speech in the park says that extraterrestrials will soon launch an attack on America. It follows that we should leave this country immediately. Okay? This is what kind of argument? Does it necessarily follow that we should leave this country? No, it is an inductive argument. Okay? Now, oddly, right, we do not have an indicator word. We don't have an inferential link. There's no strong inferential link. But we do have the form of an argument. Right? The argument contains no indicator words, and the conclusion does not follow either necessarily or probably from the premise. Right? If you see a crazy-looking person in the park, and so on, saying that the end of the world is near, we probably shouldn't, you don't need to leave the country, right? But it has the argument form of what? An argument from authority. This person is pretending to be an authority on the matter of whether extraterrestrials are coming. Okay? But we obviously don't trust usually people muttering in the park. Since x plus y equals 10 and x is greater than y, it follows that y is less than 5. Right? How is this argument best interpreted? Well, again, it's mathematics and it's not statistics, so it's deductive. What reasons support your answer? Well, we get it follows that, but that is just a conclusion indicator. We have the inferential link. Let's do the math real quick. X is greater than y. Yes, it should be that y is less than 5. So we have the strength of the inferential link, and we also get the form of the argument, which is mathematical. Okay, the argument has no indicator words, but the conclusion does follow necessarily from the premise, and the argument has a deductive form. What is the argument form? Well, obviously it's based upon one on mathematics, right? If you love me, then you respect me. Therefore, it necessarily follows that if you respect me, then you love me, right? What does this look like? Well, it looks like a shorter hypothetical syllogism. Right? It necessarily follows, right? So we get what is looking like a deductive argument. Okay? What reasons support your answer? So if you love me, then you respect me. Therefore, it follows that if you respect me, then you love me. Well, is that the case? So let's look first at the strength of the inferential link, which is not something, unfortunately, I've actually gone over quite yet. But let me go over that now, since I didn't go over that before. The strength of the inferential link means you're looking at the relationship between the sentences and you're saying, is that really the case? So, if you love somebody, then you should respect them. I think that generally, if we say, if you love me, then you respect me, a perfectly valid deductive argument would be, if you love me, then you respect me, you love me, therefore you respect me, is a perfectly valid and sound deductive argument. But it doesn't necessarily follow that if you respect somebody, then you love them, right? Just because if you love me, then you respect me, it doesn't follow that all the people that you respect, that you love, right? So you may have professors, you should hopefully have some respect for many of them, but it doesn't mean you should have love for any of them, right? So do we have an indicator word? Well, we do have, it necessarily follows that, right? So let's submit and see what else is, right? But we don't have any inferential link, and we don't have the form, any form that we have discussed, right? But the most important thing is to start to see why there is no strength to the inferential link. That is, why one doesn't follow from the other. Here's another practice problem. Anne and Cindy missed the same questions on the last test, and for those questions they gave the same wrong answers. Since the class is fairly small, it follows that these two students probably cheated. Now, I should say that this is a problem that I often deal with, right? They missed the same questions on the last test, and for these questions they gave the same wrong answers. Since the class is fairly small, it follows that these two students probably cheated. Well, we have what is an indicator word for induction, right? It doesn't necessarily follow that they cheated, right? We're dealing with the real world here. A professor is trying to guess about what Anne and Cindy have done, right? It's an inductive argument, right? And that's why we have rules and procedures when professors suggest that students have cheated, because then they need to provide inductive evidence that leads administrators and others to say that it is very, very likely the case, right? That's why in court cases, right, we don't look for certainty, sadly enough, right? We simply say what is very, very likely the case, and therefore assume guilt or innocence based upon that, right? So what reasons support our answer? Is there an indicator word, right? Since the class is fairly small, it follows that these two probably cheated. Now we have an indicator word. It follows that is the conclusion word. Excuse me. It follows that these two students probably cheated. There we get, this is a conclusion indicator word from 1.1, and this is a inductive argument indicator word from 1. Now, is there a strength of the inferential link? Actually, I think this is quite strong. If we had only 4 students in the class and these 2 students missed exactly the same questions, it's likely that they cheated, right? But is it certainly the case? No. It could be that the last 2 questions, the 2 questions that they missed were the last 2 questions on the test, and often the last 2 questions of the test are the hardest. And yet, I think that that is likely. Okay? And so let's submit that, right? Oh, and sorry, and you must get the form of argument, and we submit, right? The word probably indicates induction. The conclusion does follow from the premises, and the argument does have the inductive form that we've seen. Okay? So what is the form of argument? Is it causal inference? Since the class is fairly small, that it follows as this. No, there's an analogy. Anne is to this set of questions as Cindy is to these set of questions, right? Is that the case? It looks like an argument from analogy. No, that's because the argument does not conclude that because one thing has a certain attribute, another similar thing has that attribute too. Is it a prediction? No, the argument does not proceed from knowledge of the past to a claim about the future. It is a causal inference. The argument proceeds from the effect. The class is fairly small. It follows that these 2 students probably cheated. Why? Because then we look at the cause and we say, oh, it's likely the case that since they've answered the same questions wrong, That's why they probably cheated. Okay, it's causal inference. Okay. So here's another practice problem. The message spray painted on the wall, that is graffiti, reads the Bible is the word of God. We conclude that every statement in the Bible is absolutely true, right? So we get the word we conclude, so obviously that's a conclusion indicator. But is this an inductive or deductive argument? Well, this is an attempt to say that from a sign, or if the sign is taken as authority, that we must conclude that the statement in the Bible is absolutely true. Now, of course, we don't believe everything that graffiti ever says, but it's an attempt at an inductive argument. Okay? So what reasons support your answer? Select all of those that we have. Well, we don't have an indicator word, right? We have an indicator word for a conclusion, but we don't have an indicator word for induction, right? We don't have a strength of inferential link. Why? Because just because you see something sprayed on the wall does not mean that it's true about the Bible. Do we have the form of an argument? Well, we have the form of an argument from authority, right? And hopefully it goes there. Yep. The argument has no indicator words, and the conclusion does not follow either necessarily or probably from the premise. But the argument does have an inductive form. What's the inductive form? The argument from authority. We pretend that this is somehow an authority. Okay? Or an argument from signs, right? So the wall, message on the wall is a sign, and the argument concludes that what the sign says is true. But it's also the case that this could be an argument from authority, that you pretend that signs on a wall, as people did in previous generations, thought that, for example, people have seen the picture of, the figure of Mary in their baked toast, I'm not making this up, and then conclude that there is a divine presence and so on, right? They make that inductive argument. That's an argument from signs, and so that is an argument from signs. But this is more of an argument that somebody, the person who sprayed it, also could be an authority. So sometimes there is going to be a difficulty between whether the argument is one type or another, right? But the stronger case is to be made that this is an argument from a sign. But it's also an attempt, one could also suggest and make the case that it's an argument from an authority, that what we read on graffiti, we could imagine, is an argument, is one based upon an authority. Okay? And so there we go. We have deduction and induction, right? Arguments from there, right? And we got the style of inductive forms, right? And now we will simply leave it there. Thank you for now. We will talk about arguments, but did we get to this? Let me make sure. Arguments in science. A final argument, arguments that occur in science can be either inductive or deductive. Okay, so it is going to give us a set